All right, let's start considering the programming that's happening on this in this cell. Initially, we have three different programs. First off, we have the main bolt pallet, and we have the two-thread sealant, which is really the major moves of the program. Up here is really just all the manipulation of the indexing as well as the offsets of the positions. And then down here we have just a maintenance program, which is zero my position registers, and it takes the position register and manipulates the PRij first element to 0, and takes that same position register 6 second element and makes it 0. What do I mean by element? There are three different elements, major elements to a position. Overall there's 6, but there's usually just typically 3 that you're going to be working with, and that's X, Y, and Z. And then the other 3 are the yaw, pitch, and roll. And they are numbered 1, 2, 3, 4, 5, and 6 for X, Y, Z, yaw, pitch, and roll. So X, Y, and Z is 1, 2, 3. Yaw, pitch, and roll, 4, 5, 6. And when we create a statement like this, a position register number 6, the first element, which would be X, I want to set its value to 0. And later we'll be changing it. You've already done this where you've set certain values of an offset to be able to approach above a part and then come down to a part. This is just taking one element of that position and manipulating it or offsetting it. In this next statement here, we're taking the same PR6, position register 6, and going to the second element, which is the Y element, and making it 0. So that's out of the way. We know what zero my offsets program is about. Now let's go back up to the main program, and we'll look at the housekeeping that we have done up here. And we're setting our user frame, which everybody's used to that, setting it to 0. We have our tool frame equals number 1, payload equals schedule 1, override 30%, which will set the overall speed of this program to 30%. And you can manipulate that later if you want to speed up the program. And then we have just some more maintenance, and this is clearing out not position registers, but just plain old registers. These register 1 is used to index the conveyor length, or this direction on the conveyor. And then the R2 is used to index the width dimension, and that's the X dimension in this direction here. If we're looking at the base of the robot, it's back here. This is positive X. This is actually, if we set our right-hand rule out, this is negative Y. Remember, this would be positive Z, positive Y, positive X. The way we've laid out this cell with this conveyor and these parts on it, these bolts are actually running in a negative Y pattern and a positive X pattern. Next, I want to talk about, well, we've gone through our housekeeping, right? And we've talked about how we've manipulated registers. Before I go into the remainder of this program, lines 8 through 23 over here, I want to talk about this program right here, which is really the major moves of the program. And let's take a look at what happens when we go to this two-thread sealant program. If I just go ahead and step through this program, you can see I'm going to the first bolt, dip down, back over to the well, dip down. If I play it again, I'm going to do the same exact thing over and over again. Zip, dip down, come over. Let's break it down step by step. If I hit step, go forward, and this is the PR2 that we're looking at here. We're going over to PR2, and the next step says that PR2, I should say, has a tool offset in the Z of 150 millimeters. So it's using PR4 down here, which is our Z offset, which I look at this and go to positional value. It's 150 millimeters in the Y. This happens to be, this tool was rotated 90 degrees, so everything's a little off, but you can understand that this now is the Y coming out of the tool here, and what I had to do was offset tool 150 millimeters, and that did it in the positive Z and made it come above that part. So now I'm going to step again. Let me get out of this. Go back over to our program. And we're now going to the actual PR2. Hit enter, step forward, and now that's PR2 without the offset. If you notice, there's no offset in there right now. Well, there's PR6 is an offset, but when we look at PR6 right now, going to the positional information for it, it's all zeros. We cleared it out in the original program and made every value in it equal to 0, so it's not having any effect on this position right now. All these PRs actually have that same PR6 offset, if you know, at the end of the instruction, but they're all zeros right now, so they don't have any effect. We'll talk more about that later, and how we'll actually use that PR6 offset to manipulate going incrementally in these 4 bolts this direction, and then using that PR6 X value to go in and it'll go across these different rows. So, or we can call it going in this X value. All right, so let's step again through, forward, back to above the Z, back to home, and then back to a dip position, but notice we have a Z offset there as well, that same PR4, which we're using just to create a nice convenient approach point to wherever we want to approach whatever we're going to. We'll just offset with that Z value, and then go to that real PR3 without the Z offset, where it's dipping into the well, come back out, let's apply that offset again, come back up, go back home, and just repeat. Okay, so how does this program work where it's hitting all 12 bolts? Well, we'll have to go back to the main program to understand that. So now that we understand, though, that this is the thread sealant program, and all it's doing is going from home to this PR position here with a Z offset of 150, down to the bolt, and then back over to home, and then back over to the well with a Z offset of 150, and then dipping down into the well. Now let's go to the main program. Okay, now we're back to the main bolt pallet program over here, and that's this section right in here. And we've got past where we have our home position, right? We're going to home the robot in the main program as well. And then this is a remark. This is nothing. These yellow lines, these yellow highlighted lines are nothing remarks. Anytime you have an exclamation point, this just helps you understand what the next portion of the program is about. The green portion here says call 0 my offset PRs, which we know what that is already, right? Where that's that PR6 we're using to manipulate the X and Y, the 4 positions and the 3 positions over here. We're using that PR6 to do those offsets. Well, after we're done running our program once, we better clear that out. So that's what this is doing. Okay, now we're moving on to the main base of the main program. And this section right here says this is the column loop 1 to 3. 1, 2, and 3 is where this is manipulating that portion of the program. And then there's a for command here. The for command has always an adjacent, or has, for every for command there's going to be a end for command. And you notice there's a for command, an end for, and an end for. I try to draw these brackets here to explain what's happening with these for and end commands. When this program gets to this portion right here, it says it's going to go by this, and it's going to use this for command here to index, register 2, 1 increment, and it'll go up to 3, and then it'll be done. And then when it gets up to 3 and goes by the next, or the appropriate end for, which I put in here, ends on line 23. This line 23 here is the one that pertains to this for statement. The next for statement is to increment the 4 bolts in this direction. And if you remember the order of operations, if you watch the video, it comes down to this bolt, then to this bolt, then to this bolt, then to this bolt, and then indexes back to this bolt in the second column before it goes to this one, and this one, and so on. So this 1 through 4 is helping index in this direction here in the positive X. So, and this end, or this for statement has a correlating end for statement in line 18, which is down here. I better change this graphic a little bit here. There we go. So this for, what happens is this program runs through, skips over, or it performs this 1 for statement, but the way the book reads, or the manual reads, is that for statements work so that the for statement is affected by the next end for statement. Well, this one, the next or closest end for statement, is this one. So the way to look at this is this loop right here will be performed consecutively, and then it'll go 1, 2, 3, 4, satisfy the condition and break out of this loop, and then start going through this loop right here, which sets the tray offset 6, 1, the X value, to 0, meaning it's going to go back to that first bolt. Remember, the X direction is manipulating these positions here. Set it to 0, it's going to go back to this bolt. It was at the fourth one over here. It's going to go back to the first one over here with this PR61, which remember, PR6, that's PR6 position. First element is the X portion of it, and then making it equal 0. And then it comes down here and says, add a value to my PR6 offset to equal PR62 offset minus 200. So what that's doing is making this actually go over this portion from here to here in the minus Y. If you notice, it's the second element, right? This is the minus Y direction, and it's doing it by minus 200 millimeters. So it started over here, and then this line 22, after it gets through these 4 here, this line 22 says, okay, make that same position, but now make it equal that same position minus 200 millimeters in the Y, making it start doing this row of 4 bolts right here, or this array of 4 bolts in this direction right here. And once it does this and finishes, it hits this N4 and comes back up and starts repeating all over again, gets caught back in this loop right here, and performs all 4 functions, offsetting the in the X direction. This positive is this the positive X direction, plus 152 to increment to each bolt center. So the distance between this bolt center and this center is this 152 right here. The distance between this bolt center and this bolt center is minus 200 in the minus Y direction. So best to understand this is, let me step through this program. So let me start at the beginning here. I've got it in step mode, so I'm going to fly through this as fast as I can. And now it's calling offset my, or zero out my PRs, which I'm glad it's doing that, because if I went and looked at this PR right now, it's 0, 0. So that's what I want. Forward, forward, 0. Now it's going to go back to the program and to the next line, which is wait 5 seconds. 1001, 1002, 1003, 1005, here we go. And now we're going to do the column loop here, and for R2, this is this section right here, line 11. I'm going to step through it. And I'm going to, next is call thread sealant. You can see it, pull it up. And we already know what that does. We just watched that go. So I'm going to take it out of step. I'm going to take it out of step and go as fast as possible here. And then put it back in step when we start to get toward the end of the program. Oh, I skipped a step there, so you can understand I already jumped to the second position there. And if I look at the value, this doesn't update automatically, so let me go back and get to this and go to position. And we can see now the X value is 152. This PR6 is nothing. It's not a position we actually use. It's a position to create offsets. And now the X value is 152. So it's jumping 152 in the positive X direction of the second one. We'll step through this again and watch Let me go down to 50%. Forward. Now it's going to the third. And to the fourth. I'm going to hold here for a second because I want to show you what's happening to this value. Again, it doesn't update automatically. I go back over this, go to position, and you can see this is up to 456. Well, 152 times 4 or times 3 is 156. It's 1, 2, 3 positions up, and 456 in the X. I haven't changed the Y. We're still in the first column, so that PR6 is doing just what it's supposed to be doing. Let's continue on. Back to the well, coming back over. Now it's going to the second column. It's running the second application. It's now in. It's now gone through one of these major loops here, which is manipulated the Y value of the 6. So if I come back over here and update this guy, go escape, go back to position. Look what's happened. Now my PR6, because I just went to this position, has offset PR6 to be 200, minus 200 in this direction, and 0 to go here. And now if I go one more loop, second position, watch my value over here, escape out, position, look at 152. So this kind of makes sense now. So my X value is 152, my Y value is 200. Everything is referenced off this first position we taught. And if I go in the X direction, 152, and the Y direction, 200, minus 200, that's the place where we'll end up right here. And then it's going to go, it's going to increment that Y, it's going to stick with that X, that Y value of minus 200, because it's in this array right here. And now it's going to just increment up 152 through these, going through this loop on that second. So it's on the second value of this, stuck in this loop right here, running this until it finishes, comes out, and then it's going to go back to the third value of this loop right here, get stuck 4 times in here, come out, and then all of a sudden it's satisfied this 3 condition and this 4 condition. Basically, what this does is nest inside of it these 4 loops inside every single one of these loops. So it'll go through this for loop here, come into this second for loop, increment it 4 times, boom, 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 come out of it, add to minus 200, subtract minus 200, subtract 200, or go minus 200 in this direction, and then do the 4 loops again, and then start going down here, offset another 200, go over to this array right here, and perform 4 more of these functions to finish up. Comes back out. This says, well, I'm to my 3, I'm to my 4, I'm done with this program, I'm going back up to the beginning. So let's go ahead and run this one more time, and maybe you can watch at a slower speed. So I know right now that I'm in the second register. The value of this register is 2, and the value of this register is 3, and it's about go up to the 4th. That's that position. And now it's going to pop out of this, go down here, manipulate this PR6 with another minus 200, making it go to 0x and minus 400y into this position. So bounced up here. Now it's stuck back in this loop right here, manipulating the this array value here with this plus 52, the x value. Okay, I hope that helps understand what's happening with these 4 loops. If you need more help or information on building out the PRij offset instructions, that's how to build that PRij equals PRij plus 152 kind of instruction, please see the video specifically on the PRij instruction. I hope that helps. If you need more information, please email. Have a good day. Let's talk about position registers, and more specifically how to build out position register offsets in the TeachPennant program. I've got 3 examples here, actually just 2 examples. This is a repeat and manipulating different portions of the offset. This is a simple tool offset. They look similar or perform similar operations, but this one is completely different in that it's just an option at the end of a motion instruction. These are actually manipulations of data within the data portion of instructions. So let's build out an example. For this one right here, I'm going to build out line 2 in line 4. So let me go to create a point. Change this to a position register so it can be manipulated. Let's call this position register 3 like we did above. Come to the end of it, and we have the ability to do a choice here and add an option. If I go to the next page, you'll see these 2 tool offsets. One's a tool offset, one's a tool offset PR. The difference is this would be an option to add a direct offset measurement. So I could add 150 millimeters here and be done with it. This is add the offset that's in the value of this position register. And if you remember, we made the position register 4 equal a Z offset 150. Well, here's the offset. It's not a Y. This is not the best example. Real quick, on this gripper up here, we had to rotate it 90 degrees, which threw off the measurement that we do this offset in. So just pretend this is a normal offset and we do a Z value, but in our circumstances, we have to use the Y value. So in this case here, I'm going to put this PR value to that of the position register 4 that we're using for our offset, and we just built out that same exact value. Let's go back again, take a look at this option. If we go to choice and look at, if I made it just a tool offset of 150, I could have accomplished the same thing. The convenience of adding a position register offset with a position register offset, I can set that value to 150 now, but later, if I decided that's too big an offset, I really only needed 100 millimeters, I would just change the value here to 100, and it would change all the offsets, all the approach offsets that in my whole program. Everywhere where I've used this PRZ offset, I could change it globally with this one statement. So that's the benefit of a PR offset versus a tool offset using a PR versus just using a tool offset. Okay, that said, let's go to position register IJ, a PRij offset. This is a unique animal and is not the most intuitive to build out. In this case, I don't go and build a motion instruction. I'm just manipulating a position register. In this case, I'm going to go to Instruction, Registers, and I'm going to use option 2 here, which says blank equals blank plus. And this is a generic, can be used for many things, but we'll build it out here and say, so I'm going to select number 2, and here's where you see the PRij option available. It's kind of buried in here, it's kind of hidden. So I'm going to select option 3, and then my PRij is right here. This is the I, and this is a J. The I is the position register number itself, which in our case is going to be 6. Enter. The element, the J portion of it, in this case I want to manipulate the X, so I'm going to pick element 1. Enter. Now, you'd think you'd add a constant to it to add on to that IJ, but it has many options where I really have to specify what am I going to be doing with this X element. And what I'm going to be doing is adding it to itself. So I'm going to go to the next page, and pick the PRij again, buried 2 next pages over into the 3rd page, and pick PRij. And then I just repeat what I said before because I'm manipulating the same exact element. Oops. And now I'm going to add that constant to it. And this makes sense when you look at the operands. It's saying make the x element of PR6 equal to the x element of PR6 plus this constant, which in our case is going to be 152. I hope that makes sense. You might have to rewatch that a couple of times to understand it. And then down here, we're just going to rebuild line 10, PR6 second element, which is the Y element. Let's do it again. Let's go to instruction, registers, this second option here, PRij. Again, we're going to the 6 PR6 second element, the Y element, and then we're going to go next page, PRij, and 6 PR6, enter, second element, Y again, and add a constant to it. And in our case, we're actually going to change this operand here to a minus. See how I did that? And in this case, it's going to be 200 because we're incrementing 200 millimeters in the negative Y direction. From this position to this position, if I use my right hand rule, coming out this way is positive X. This direction is positive Y. We're going negative Y, which is this second element here, minus 200. Kabam. I hope that helps on how to build out PR offsets in the Teach Pallet program to build the instructions. If not, contact me and let me know. Thank you.